This is section 9.3, one-tailed test. We'll also see that sigma is unknown. Here is your formula for your test statistic. Looks very similar to what we did earlier. Stop the video, read the problem, and write down notation as you come across a number. We wish to determine whether the new process has a mean that is less than 189. That's why you see less than here. H sub 1 will always be what you're testing. Remember, your equal sign is always an H sub O. If mu is less than 189.49, that means H sub O must be mu is greater than 189.49. And we're doing the traditional method. So, sigma is not known, so we're going to have to use our t-table. And we also know alpha is 0.05. And this is a left-tailed test. So you don't divide it by 2 because you only got 1, 2. And there's your alpha, 0.05. Okay, that's in the tail. Now, I know your t-table says upper tail area, and we're in the lower tail, but you're still going to go to the column that's 0.05. And degrees of freedom is n minus 1, which is 24. So go over to that one, and where am I? 0.05, that's the third column over, 1.7109. And that's the number we see here, but of course I'm to the left of 0, so it's going to be negative. Okay? And that number separates the critical region, which is here, from the non-critical, which is all this. So use that formula from above, substitute in your numbers, and you get t is negative 3.2136. Now, where would negative 3.2136 be? It would be down here in the tail somewhere. And what region is it in? It's in the critical region. And if your test statistic falls in the critical region, you reject H sub O. We are rejecting that. We're saying this is true. So, write your summary. There is evidence support that the drive-through time is less than 189.49. All right, stop the video whenever you need more time to write. Now, number 2, very same problem as number 1. It's just this time we're going to use a p-value approach. Am I correct? So, different method, guys, p-value, okay? So, what you do, this t, negative 3.2136, is there, okay? That's the dividing point between the critical and the non-critical region. And then pH stat, I'll do a separate video for that. But from pH stat, I found a p-value to be 0.0019. And you write down that number, 0.0019. And alpha is 0.05. And what is it? That's less than. And if the p-value is less than alpha, you reject H sub O. That's by definition. So, same summary as before. There's evidence to support that the drive-through time is less than 189.49. All right. Still in section 9.3. Read the problem. Stop the video. Write down in notation what your numbers are. Using the alpha is 0.01. Level of significance. Is there evidence that the population mean weight of the chocolate bar is greater? So your H sub 1 is going to have a greater than, because that's what you're testing. Mu is greater than 6.03. That means H sub O has got to be everything else, otherwise known as U is less than or equal to 6.03. We are doing what method here? We're doing traditional, critical value approach. So the next thing I do, I go to alpha. We know it's a right-tailed test, so I'm up here. I put alpha in the tail. I pull out my t-table because the population standard deviation is not known. My upper tail area is 0.01, and I go to 49, and I see the number 2.4049. This number here, okay? Now we calculate the test statistic. That's what we're doing here. And we get 1.414. Now, where would that be? Where will that be? It's going to be, if this is 0, it's going to be in between 0 and 2.419. So here's my test statistic. It's in the non-critical region. So what does that mean? Do not reject H sub O. So we're saying this is true. There is not evidence to support that the weight is greater than 6.03 ounces. That's traditional method. If I do p-value, which is what I've done here below, I take this value here, and that becomes my dividing line, 1.414. In pH stat, I got a 0.0818 is my p-value. 0.0818 is what my confidence level significance is 0.01, and it's greater than, so do not reject. So you would have the same. Oh, now I'm in 9.4. Good. And this is the z-test. This is more hypothesis testing, except it's for a proportion. And we should know that lowercase p is the sample proportion. Pi is for the population. And so the z-test statistic follows a standardized normal distribution when x and n minus x are at least 5. Okay, and that's normally going to be the case, but you'll check it. As long as they're at least 5, greater than 5, then you can use the z table. Stop the video and read the problem. Write your notation down on this side or wherever. So what are we trying to find there? Is there evidence that the proportion of internet users who said they had taken steps to remove or mask their digital has changed? Has changed. Does it say increase or decrease? No. That's why you've got not equal in H sub 1. And that was not equal mu. And the way we got that was from P, 681 over 792. Gave you the P, and then pi is 0.8 because of that right there. Okay? Now, check it. Number of interest is 681, and sample size is 792 minus 681 is 111. It's greater than 5. That difference is, so we can use the z statistics. And here's your z stat formula right there. P is 0.8598. So I calculated that z here, and I got a 4.21. So I've got ahead of myself. This is a two-tailed test. That and that. Alpha is 0.05, but you got two tails, so divide it by 2. In each tail, you got 0.025. So I went and looked in the guts of my table. Well, no, I didn't. Depends on which table you're using. I did 0.5 minus 0.025 and got a 0.475 right there. Is what that is. I looked in the guts of my table for 0.475, and I found the closest z to be 1.96. And I've got the negative one down here as well because it's a two-tailed test. I then calculated my z. I put this number on my graph, and it's way up here in my tail. It's in the what region? Critical. So reject H sub O. I'm rejecting this. So we're saying this has some validity. There is evidence that the population proportion of all internet users to remove digital footprints has changed from 0.80. This number here, and that became my line to separate between the critical and non-critical. Same thing, p-value approach. I got my p-value from PHstat, and it was 0. So I took my, so there's that. And then I found the p-value using PHstat, and I got 0 and 0. And 0 plus 0 is 0. And 0 is less than 0.05, so you reject H. So you reject H sub O. Same summary as the previous page. All right, read the problem. You know what to do. What am I trying to find here? Data are collected from a sample 400 orders using process. The results indicate 378 were filled correctly. At the O1 level, can you conclude that the new process has increased the proportion of orders filled correctly? So that's why increase. That's why you got a greater than here. That means H sub O will be less than or equal to. And I'm doing the traditional method. So what did I do? I took, this is right tail test because you've got greater than in H sub 1. All your alpha is in the right tail, 0.01. I looked in the guts of my table because n minus x, 400 minus 378, is greater than 5, so it's legal to use the z. Where am I? 0.01, and then 0.5 minus 0.01 is 0.49. Look for 0.49 in the guts of your table, and the corresponding z was a 2.33. So then I calculated my z statistics, and I got 3.86, and that would be up in the tail. It's in the critical region. I'm going to reject H sub O. There is evidence that the new process has increased the proportion of correct orders to 88.3. Next page. Oh, I'm on the last page. That's it.